Hello and welcome to the fourth video in the series of 3D scanning, 3D modeling, and 3D printing a box that will fit beautifully into the side of a Resolve mini panel. The idea being this box will house 2 StreamDecks and 1 Trackball. In previous videos we have scanned a Resolve mini panel. We have used that scan to build a box for the StreamDecks. We then changed our mind about that box and we rescanned the panel to get a little more accurate scan and build a box that was more of the curved shape of the Resolve mini panel. Along the way, we took that shape that was very flat on the one side and we decided we were going to make it more curved so that the Resolve mini panel would sit a little closer to the edge. And at the time, you'll remember I said, I don't think I'm going to fill in that gap entirely because that will end up being a lot of wasted plastic. Well, of course, I changed my mind. I have adjusted that curve even more so that the next model you see will have an even bigger curve going underneath the Resolve mini panel. I also adjusted the curve at the top so that this angle is no longer flat. This angle as well has a curve on it to follow the Resolve mini panel. I did those off camera just because they're the same techniques we've been using in other parts of the other videos, so I think it's time we start jumping ahead to the trackball. And today we're going to do the trackball. We are going to rescan the trackball. We're going to scan the side of the trackball and the bottom of the trackball. We're going to bring those shapes into Fusion 360, and that will help us get an overall shape to help cut a hole in our trackball box. So let's get going and see what happens. We want to put a trackball right into this little section here. The idea being that the trackball is going to sit on an angle that is flush with the angle of the top of the mini panel, and we also have a very specific shape in the trackball. So we want it to sit in this part of the box, but we want it to look nice and custom. So what I've done is I've gone and I've rescanned my trackball. I've got a side view and a bottom view of it. We used masking tape and Play-Doh to get a nice perspective and a nice scan on the trackball. And we did 2 different scans, one for the side, one for the bottom. So let's bring in the side scan. And once again, I do have to do a little bit of maneuvering to get this to be the right orientation next to the mini panel. So I'll just take care of that. Okay, so this is the angle we want to match to the trackball. And we're going to want to angle this so that this is actually flush with the top of the trackball panel, the mini panel. Our next thing we will have to do is bring in the bottom of the trackball and go through the same process of twisting and turning and spinning and flipping and rotating and trying to get it nice and flat on our drawing. So once again, I will work on this and we'll get it into position. So that's pretty good. We've got the base lined up and we have got the side lined up on this angle. So together we should be able to build something now to get this trackball shape into our system. So we're going to do the same thing. We're going to build a sketch. We're going to trace out the side and the bottom of the trackball to get a cleaner version now. Again, the scan just helps us get that original shape into the program. So as I whip through this sketch creation, we'll come back once we get this all straightened out. And that looks pretty good for the side. Just a couple of minor tweaks here and there. But again, we just want to get that top angle close. We're going to take this and we've now basically extrude that out and get a fake view from the side of the trackball. And we're going to do the exact same thing now on the bottom. We're going to trace around it, smooth them all out, straighten them all up, and try to get this shape as close as we can to the trackball shape from a bottom perspective. And once we have that, we will do the same thing. We will extrude that out. It doesn't have to be a specific size at this point, but we will get it to the point where we have a fake trackball from the bottom perspective and a fake trackball from the side perspective. We will line these up now to try to cut our hole into our box. Now what I have to determine is the height that the trackball has to sit at in this box, as well as the angle the trackball has to sit at in this box. We can use the side view that we've built for the angle, but to get the height is going to be a little more difficult because the shape of the base is an arbitrary up and down height. And I can see right here that we're going to have to extend the size of our box out a little bit, as our trackball is a little bigger than what we had allowed on our original build here. So now that we've expanded the size of the trackball section, we can now comfortably lay our trackball base into it to make sure it fits. This will be the basis for cutting out a hole in the trackball box. Now to make sure that the trackball fits into this hole, I'm just scaling up the overall shape by 0.04 millimeters. If I do too close of an exact match to the trackball, it won't quite fit, because 3D printers just aren't that exact in what they're printing. So I'm just ensuring I have enough space all the way around for the trackball to sit into this slot. And by expanding that up, that 0.04 millimeters, I'm faced with the same issue of the box being just a little too small to fit this trackball in. So once again, I'm going to have to extend the size of this box. And we want it to be fairly tight on the sides, but we want to make sure we have some support material on the sides of the box. So there's no use in getting too tight to the edge. Let's make sure we have, a little bit of comfort zone that this is not going to fall apart if we bump into it or something. Let's make sure we have some structure on this box. Typically I go with 4 millimeters from on the sides, I just find that to be a nice piece of plastic on a frame to make sure it is sturdy enough. And I think we now have a box that is big enough for this trackball to sit in, but not too small that the trackball is going to, or the structure is going to be weakened. So now we have to determine the angle that this trackball cutout is going to sit at, because once again, I want the top of the trackball to be in line with the top of the mini panel, where normally the trackball sits at an angle from back to front going down. We want to adjust for that angle and almost make the trackball appear to be flat against the mini panel face. So again, I've got the side view of the trackball now, so I'm going to bring it in and I'm going to try to get it as close as I can in perspective to the side of the mini panel. So using the sizes and the shapes of the trackball that we have built, I used the trackball base shape to cut a hole in our trackball box. Same way that we cut our StreamDeck hole in the StreamDeck box. What I found was I needed more than just that base shape to cut the hole, because again, remember, I want the angle of this trackball to sit at the same angle as the Resolve mini panel. The problem was the shape of the trackball feet when extruded up was great, but it wasn't at the right angle. So I was cutting straight down into the box when I needed to be cutting at a bit more of an angle. And the combination of that angle and that depth was very hard for me to come at. What I figured out I needed to do was combine the two shapes, the shape of the base extruded out and the shape of the side extruded out. I needed to combine both those shapes into one shape that more accurately represents the trackball. So I have done that. I did an intersection combine. So I took those two shapes that we have, combine them together with the intersection tool. That cut everything away but where the two shapes intersected. That left me with essentially a trackball shape in 3D from both the top and bottom perspective and the side perspective. I could then use that to cut a hole in my trackball box. That left me with the proper shape, the proper depth, the proper angle of the trackball to fit into this box. So let's just take a quick look now at the cross-section analysis of this, and we can see that we've got a nice strong base all the way through. We could try to hollow this out, but that might end up just needing to be printed with support material anyway. So I think this is what we're going to end up using as our trackball shape. It's a little thicker on the bottom than I had wanted, but I think we will survive. And as you can see now, I've expanded all the sides so everything matches up. The boxes, all three boxes are now the same size width-wise, and I've made the trackball holes centered up on those boxes. We're all good from that standpoint. A little bit of back and forth on that section, trying to get the size of the trackball and the size of the StreamDecks to all line up. Took a little bit. And you can also see on the top trackball, I did round it off a little bit more. I have put the angle to try to fill in between the top of the trackball and the top of the mini panel. I wasn't sure if I wanted to do that, but I decided in the end this should match as closely as we can. And as I had said earlier, we adjusted the angle going underneath the track or the mini panel a little bit as well, so we have a little steeper angle cutting underneath the mini panel. Just little tweaks here and there just to try to finish this off from a visual standpoint to make it a little cleaner. So just to explain what's going on here, a little change in what you're probably seeing. The StreamDeck boxes are smaller than the trackball box, and that's not what I want. I want everything to look like one big box in the end. So as I had to expand the trackball box out to get it to fit the trackball, I then had to expand the StreamDeck boxes out by that same amount. That left the StreamDecks themselves, the cutaway for the StreamDecks, no longer centered on those boxes. So then I had to move the cutaways for the StreamDecks over as well to compensate. In the end, it leaves me with one big box that is the right size from top to bottom, and everything is centered on that box. But I just wanted to explain to you why it maybe looked a little bit different in this video than it did in the previous video. Now, in order to print this, we have to break this into 3 parts. And in order to put this back together after we've printed those 3 individual parts, you'll see that I have put some pins into each one of these sections. Just basic cylinders that I'm going to combine into a middle StreamDeck section. And then I use those cylinders to cut a hole into the front trackball section and the rear StreamDeck section. So now we have to get these pins to cut into the other two sections of the box. So if I turn on the back StreamDeck, we're going to use that pin as a cutting tool, and we're going to cut into the trackball, or the StreamDeck section. Now we did make sure we lined these pins up to a point where they were going into the trackball section and the StreamDeck section where there was plenty of plastic material. So it's just a matter of selecting the pins as a cutter, selecting the StreamDeck section as the section to be cut. I want to make sure I keep my cutting tool around because I need those pins to stick around. And that leaves us a hole in the back trackball section for those pins to slide into. Now, the fact that the pin holes are the exact same size as the pins right now means more than likely they won't fit together. 3D printers just aren't that precise when they print stuff out like this. So what I want to do is go into each one of these holes, and I'm going to expand them so that they're a little larger. I think I usually do 0.4 millimeters bigger than the pin that is going into the hole. And that's just kind of experimentation on my part from previous models, depending on my printer. And for my printer, I've found that this 0.4 millimeters is a nice area where the pins will slide in but not fall out. They're tight enough to get in, not so tight that they break while I'm putting them in. If I want to glue these pieces together, I could. If not, there's probably a pretty good chance these pins will be strong enough and will hold tight enough that I won't need to glue them. But I'm going to do this on all of the holes that I end up making for the pins. And then once we're done on this back section, we'll do the exact same process on the trackball section. And here you have the 3 pieces that I want to send to the printer. So we're going to select each one of these sections and individually send them to our slicing software. We use Cura for our slicing. A little bit of numbers for you right now. The StreamDeck Upper took 31 hours to print. I kid you not. And this is a time lapse of that print, 31 hours. StreamDeck Lower took 18 hours, just about 19 hours to print. And the Trackball took 17 hours to print. So by my math, we're looking around 60 hours of 3D printing time. It's a lot. My wife wasn't happy with the constant whirring of the 3D printer for the last 4 days, but thus is life. Anyway, what I have ended up with, and I told you at the beginning we were actually going to see some results from this. Here is the trackball box. We have a shape that's very nice. We have a hole cut out right here. I'll see if get the light to hit it there. That is support material. I have to pop that out with a screwdriver or a jackknife. It's basically a serrated edge in there. And same thing for the 2 pinholes. They are filled in right now. That's a function of 3D printing. You have to print what's called support material anytime you're printing over top of wide open space. In this case, the holes, the square part, is over top of wide open space. So I have to pump those out, but I think we're looking pretty good. The StreamDeck Lower section, same idea. There's my pins. They did have support material on them as well because, once again, they are over top of nothing. They printed out in this orientation. And to get that to print out, it actually printed little support pieces underneath them to hold them up while the print was happening. So I've taken those off. The USB hole in the back also needs to be taken out. And the USB hole on the interior, if I can get that angle for you, get some light in there. This wall here, this back wall, is actually all support material because it actually cuts in at an angle. So again, I see a serrated edge here. I'll have to cut that out. And we'll show that very shortly. But again, look at that angle. Looks really nice. Fits really nice against the mini ball or mini panel. And the final one, the big one, the 31-hour print, is the StreamDeck upper section. And once again, if we orient, that's how it actually sits. So we've got the side here that goes against the mini panel. Again, we did do a curve both top and bottom on that, so that this goes underneath the mini panel section and this goes along the lines of the upper part of the mini panel section. I put a curve off on the top just because at some point obviously I had to get back over to this side. The USB hole on the back still has some support material, as do the two pinholes. And these little two smokestacks here are all support material as well that I have to pull out. I have to do those gently because I don't want to break up top. And that will leave a nice exposed hole underneath, if you can see, where the StreamDeck will go right in here. But again, because it was printed in this orientation and the angle that's in here in this hole, I wanted to make sure it didn't collapse during the print, so I put support material in here. A little bit of wasted plastic, but I think on a 31-hour print, it's worth that little extra plastic so that I don't have to do this again. So let's get the support material taken out of this and see if we can get these three pieces put together. Okay, time for the fun part, I suppose. Let's get the support material out. So again, every time you do a print over top of basically midair, you have to print support material. And for the most part, it's designed to just pop out without too much difficulty. Now, I know the trackball section, most of this should come fairly easily out. So, I mean, that's essentially the trackball. Let's, this is like the moment of truth here. Luckily, any of these holes that don't quite fit, we could always drill them out. And there you go. I've got a hole that doesn't fit. I've got too big of a plastic rubber on this thing. But so we're going to have to, well, you know what it is? It's the base going down is intercepting by about half a millimeter, 2 millimeter, 1 millimeter, not even a millimeter. We've actually got a hole, but the base is covering part of that hole. So we're going to have to we can just scrape that out with a X-Acto knife. It'll work. That'll be fine. The actual shape is pretty good. Once the cable's going out the back, it'll sit forward. It'll sit back a little bit more like that. That's pretty good. I'm pretty happy with that. I think that'll fit in nicely with the mini panel. Let's go to the midsection. This one's going to be a little more difficult because some of the support material is actually inside. So our holes, same thing. If our holes aren't quite there yet, and they're not, we might have to take a little drill bit and just hand spin these, and we'll get those in. But that's, again, that's not a big deal. I did 0.04 offset to make these holes bigger, and I guess the printer hasn't been quite accurate enough for that. And then the StreamDeck itself, look at that. That is beautiful. That is beautiful. Perfect fit. So, very nice. And the last one, if you've ever done any 3D printing, you learn the bane of existence of support material. So sorry, at some point as I was doing all the support material, the camera battery died, so I lost you. I didn't catch it until just now. But same process over and over again. You're just pulling plastic out. But in the end, I think we're really close. We have to expand our holes a little bit for our pins. We have to expand our holes a little bit for the USB cable. We'll just use a drill bit and we'll just hand do it on these, and that'll make those work. For the USB cable, I'll probably just take the Dremel and just shave a little bit off of that. And then after that, we're going to sand and paint this, and we're going to do that in the next video. So if you've stuck through all of this so far, thank you, and we'll see you on the next one when we wrap this whole thing up. Thanks for watching.